Okay, we are going to pick up with where we left off on chapter 10, and I'm just going to write a brief outline for the three things we're going to cover today. One, we're going to cover acid, base, strength. It's the first thing we'll cover. So we're going to get familiar with the idea that there's weak acids, weak bases, and strong acids and bases as well. We are going to look at equilibrium for weak acids. And you need to take note that it's weak acids that we're looking at equilibrium for. And then lastly, we are also going to look at equilibrium for water. And it will be pure water, water only, okay? So these are the three things we will cover in this video series. So you need to be well versed in these three things before you move on to the next video series. So let's start with the first one, acid and base strength. So like I mentioned, there are strong acids and weak acids. There's no need for you to memorize a whole list of strong and weak bases or acids, but we do need to know how to differentiate, how to tell when an acid will be strong or weak. Same for a base, vice versa. So let me start with what this slide says here at the top. Hydrochloric acid, HCl, and vinegar, which has acetic acid. This is acetic acid. This was in your titration assignment you did this week. They're both acids, but if I ask you the question right below that, which one would you be willing to ingest? I hope that your answer would be acetic acid, right? And not vinegar, or sorry, not HCl. We would not want to ingest HCl. It's highly corrosive, but we could ingest vinegar. We know, maybe you have been around long enough to know that HCl is highly corrosive. Vinegar is edible. We use it in cooking. There's all kinds of vinegar you can buy at the store. But why is this? Why is one edible and one highly corrosive and they're both acids? So this all boils down to acid strength. And what really gets at this, what really answers this, is it all depends right here on how easily the acid, and we're going to use this word, disassociates. And what we mean by that is how easily the acid gives up the hydrogen ion. Okay? Strong acids, I'm going to put an arrow up here. Strong acids completely disassociate. All right? So if we had 10 molecules of HCl to start out with, and it reacts or it dissolves into water and aqueous solution, what we will end up with is 10 molecules of the hydronium ion and 10 molecules of the chloride ion, and we would have 0 HCl left over, okay? Because every single molecule of HCl would disassociate. That's what we mean when we say it completely disassociates. That's a strong acid, okay? A weak acid does not completely disassociate. A weak acid partially disassociates, okay? So if we started out with, let's say, 10 molecules of acetic acid and it partially disassociates, we don't know exactly how many, but we could say if it's a pretty weak acid, then maybe we'll end up with, 4 molecules of acetate anion, 4 molecules of the hydronium ion, and we would still have 6 molecules of acetic acid left over, only 4 disassociated. Okay, that's what we mean by it partially. Some molecules of acetic acid did not disassociate. All right. Additionally, what you might notice is that for a strong acid, we draw a single arrow, okay? The arrow pointing to the products is a single arrow, meaning we do not get a reverse reaction. All of the reactants go to make all the products. But in a weak acid reaction, we have a double arrow. What that means is that some of these molecules on the product side will react together and remake our initial reactants, okay? So these statements down here are what we have explained, a strong acid completely disassociates in water. You need to remember that. And a weak acid partially disassociates in water. And because it partially disassociates, we get a reversible reaction, which means we have an equilibrium, okay? You guys are familiar with equilibrium now. We talked about this in chapter 7, so we're going to dive back into some concepts of equilibrium with acids now. All right, same idea with bases. Bases also have relative strengths. We have some strong bases and weak bases, but what does it mean if you're a strong base? What does it mean if you're a weak base? Let's look at the first one. Strong bases have a high affinity for the hydrogen ion, okay? That means it binds them really tightly, H+. They really like to bind H+. Weak bases have a lower affinity for H+. Okay, binds H+ weakly. They both are bases. And remember the definition for a base. We said a base equals a proton acceptor. Okay, so both are bases. They both accept protons. And remember, when we say proton, we're also meaning the hydrogen ion. It's just that strong bases do so very tightly. High affinity for H+, weak bases do so very weakly. Okay, if you look at these two reactions down here, the strong base example that's given, sodium hydroxide, remember anything with OH minus. OH minus is a very strong base. So any ionic compound that has hydroxide in it is a strong base. If it reacts with an acid, and we abbreviate acid HA, okay, A stands for acid, and H is just indicating that it does have a hydrogen it can give away. Remember, to be an acid, you have to have a hydrogen in your chemical formula. So there's the acid. And that hydroxide ion is going to grab that hydrogen from the acid, and it's going to make water. And it's going to do this with a one direction arrow, okay? It's going to only make products. There's not going to be no reversible reaction. Okay, you only get products here. Weak bases, though, similar to weak acids, you're going to have a reversible reaction. Okay, some of the products will remake the reactants. Okay. All right. So now that we have explained that, make sure you can, if I give you different equations, chemical reactions with a single arrow or a double arrow, you could look at those reactions, and by looking at the number of arrows there, you could tell me if the acid or the base in those reactions were strong or weak, okay, based on if you had a reversible reaction or not. Here is a really great table. This is in your textbook. It's table 10.1, and it just talks about the relative strengths of acids and bases. You can see on the left side where the red arrow is. Down at the bottom, we start with these really weak acids, and as you go up, the arrow gets darker and darker and darker, and the acids become stronger and stronger. So as you go up the table, if you start at the bottom, you go from your very weak acids to your weak acids here, and then we have our strong acids up here. There's 6 strong acids, by the way. You do not have to memorize these, but it would be good to be familiar with this table, okay? On the other side of the table, where you see the blue arrow, we have the conjugate base of that acid, okay? So pause. If you don't know what I mean by conjugate base, pause this video, go back to the videos from Tuesday, and watch the video on conjugate acids and conjugate bases, because you need to know what conjugate base means, okay? It's the acid without the hydrogen, because it's already given a hydrogen ion away. Okay, so it's what's left over after the acid dissociates. That's the conjugate base. All right. At the top of this table, we have weak bases. All right. And as you go down, the arrow gets darker and darker. And at the bottom of the table, we have our strongest base we know, which, as we've mentioned, is the hydroxide ion. Okay. One thing to point out here is that the stronger your acid is, the weaker its conjugate base. Okay, the stronger the acid, I'm going to write that up here too. The stronger the acid, the weaker the conjugate base. All right, so really strong acids have really weak conjugate bases, and really weak acids have really strong conjugate bases. A great example is down here at the bottom, water. Water is like the weakest acid we know. We really can't even call it an acid, but sometimes it does play the role of an acid. But its conjugate base is the hydroxide ion, and that's the strongest base we know. So, know that trend from this table. Look over this table. You will have this table on exam 4. Okay, this will be given on exam 4. Okay, but just know how to look at it and analyze it. All right.